All right, so today we're going to talk about scientific notation, part 4 of Unit 1. And scientific notation is just an easier way of writing really big or really small numbers. So, for example, 24,500,000 could be written a little quicker in scientific notation by calling it 2.45 times 10 to the 7th power. Now, what have we done here? We've created what's called a coefficient, which is a number that has to fall between 1 and 10, and then an exponent, which is essentially how many times I would have to move the decimal in that 24,500,000 number until we had our decimal between, our coefficient between 1 and 10. So that 10 to the 7th just basically represents 10 multiplied by itself 7 times. And so, another way to look at it is with my original number, 24,500,000, I would have to move the decimal to the left 7 times total to get that 2.45. And so again, that's where I got the 10 to the 7th power. Try this example, 58,000. How many times would you have to move the decimal to create a coefficient that falls between 1 and 10? We should have said 1, 2, 3, 4 times. So that would give us a coefficient of 5.8. But we can't just say 5.8. We would have to also say times 10 to the 4th power, because that's how many times we move the decimal. We can also move the decimal the other way if the number is already in scientific notation. So 6.02 times 10 to the 4th power. If we start with 6.02 and we move it to the right this time, 1, 2, 3, 4 times, and then fill in zeros as placeholders, we get the number 60,200. And then we can also take really small numbers and write them a little quicker in scientific notation. So if we look at this number, 0.000305, our coefficient is not between 1 and 10. So this time we're going to have to move the decimal to the right to accomplish that. And so we have to move it to the right 4 times to get it between the 3 and the 0. But this time, since we're moving it to the right, we have to say 10 to the negative 4 power. So again, just to illustrate, moving to the right 1, 2, 3, 4 times. So a really small number, a number much smaller than 1, will always have a negative exponent. So try this one. How many times do you have to move the decimal to get that coefficient to be between 1 and 10? All right, it looks like 1, 2, 3, 4, 5, 6 times total. So 1.10 times 10 to the negative 6 power. Notice I kept that sig fig at the end, that trailing 0. So I have 3 sig figs in both numbers. All right, and then if we're starting with scientific notation, we want to give ourselves lots of space to the left of the coefficient this time, because we're going to have to move the decimal the opposite way, to the left. And so this time we're going to move it 9 times. Okay, and then that means we fill in our zeros, all of our little placeholders there, and then we can write our 0 in the 1's place as well as the decimal. The last thing we want to say is you have to know how to use your calculator in scientific notation. So sometimes we multiply or divide in scientific notation, like this number, 6.70 divided by 3.21 times 10 to the 7th. On one of my calculators, the way you're going to enter this, it starts out pretty normal, 6.70. So you just type in 6.70 and then divided by 3.21. So far everything's normal. But then we're going to use the EE key, which is down to the left here. And then we're going to put in the 7. Okay, so that would mean, 3.21 times 10 to the 7th. It would show up on the calculator as 3.21E7, but it means times 10 to the 7th. On a scientific calculator like this one, it's the same thing. The only difference is when you go to press the EE key, and you might be able to find this one if you have your calculator with you now, it's right there. You have to hit a secondary function and then hit the EE key. And either way, you should get 2.09 times 10 to the minus 7 power. So if you have your calculator with you, or if you have a calculator with you that can do at least scientific notation, give it a shot and see if you can get 2.09 times 10 to the minus 7 as your answer. So we'll work on this in class some more, and we'll use this throughout the rest of chemistry because we have lots of really big and really small numbers that we deal with.